Hello, this is an exercise for Year 12 Further Maths. We're looking at those questions where we're asked to count out how many different ways something can take place, where some of the objects are either kept apart or together. So, together or separate, then is basically the idea of this PowerPoint. So if we just have a look at our first examples. This one, it's all together or keeping some objects together. So my first one says, how many permutations are there of the letters of the word together if the E's must be kept together? Now the way, first of all, to do this is obviously we need to see there's two E's. How many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. I make that 8 letters. So normally if it was just no restrictions at all, we'd say it's 8 factorial, and then we'd divide by the fact there's some T's and there's some E's, etc., etc., and you'd have to divide. But here we're going to treat the E's as one letter. Effectively, it's an EE next to each other, because they can go, they must be kept together, it says. Now, after we do that, then effectively we've only got, if we think of this as 7 factorial left. So let's just do it like that. We'll think of this as 7 letters, but the EE must be together. So, if that's true, what else have we got? We've got 2 T's. We're going to have to divide by the fact there's 2 T's. Is that it? I don't think there's anything else there which is, repeated. So if I do this, 7 factorial divided by 2 factorial. And the key is, I suppose, treating it as a double E, as one letter, as opposed to worrying about any other way. So what's the answer? 2520. Next question. How many permutations are there of the words together if the E's must be at the start or at the end of the word? If the word to... And I think this is what it refers to here. I'm not exactly sure. It's got to be EE followed by all the other 7 letters. It's 6 letters, isn't it? 1, 2, 3, 4, 5, 6. Or I suppose it could be the other way round, 4, 5, 6, and then an EE at the end. So that's what I think it's doing here. So you'll notice now effectively, if we have them right at the start, or if we have them right at the end, well, there's 2 ways of doing that. I can see that here. So whatever I get, there's 2 ways. And I think there's 6 factorial. For the others, well, not quite, because I've got 2 T's there as well. So I've still got to take care of the T's. So I think it's 6 factorial divided by 2 factorial because of the T's, but then times by 2 because the E and the EE can go at either end. And I think that's it. So effectively, they cancel out. And my answer then is 6 factorial. And what do I get? 720. Good, 720 is right. I've done exactly the same way. So we're starting to see these questions now, the types of questions that can come up in exams. How many permutations are the letters of the word candle if the vowels must be kept together? So again, what vowels have we got? We've got an A and we've got an E. Now, that's interesting. Notice last time we did EE. AE could be together as AE or EA, so I need to take that into account. So let's do this then. So if I treat AE as one letter, 1, 2, 3, 4, 5, 6 letters. So I'm going to pretend it's only 5 letters. I'll do 5 factorial. But I've got to times it by 2 because it could be either way around. Are any letters repeated? No, they're not. No letters repeated. It's just 5 factorial times 2. 5 factorial times 2 then is 240. They must be at the end. How many permutations are there of the letters of the word candle if the vowels must be at the end? Well, again, we've got a similar situation. 1, 2, 3, 4, and then AE goes there. But 1, 2, 3, 4, or EA goes there. So it's either, again, I think there's 2 ways to do that. Notice not allowed to be at the start this time. So I think in this question, there's 4 letters left over. And I think I times by 2. So 4 factorial is 24, times by 2 I think is 48. And 48 is my answer, good. Another one here. How many permutations are there of the letters of the word canoe if the vowels must be kept together? Well, you can see the vowels. In fact, there's 3 vowels. So you've got A, O, E. Now, when the last time I had A and E, I was able just to say there's 2 of them. Now, when you get into more complicated letters, it could be A, E, O, Could be EAO, could be EOA, could be OEA and OAE. Now you'll notice that is basically 3 factorial ways of arranging those. I've got 6 ways, if you like, of arranging those. Now they must be kept together, so we're going to treat them as one letter. So we've got a C, an N, and the vowels. The C, the N, and the vowels I'm going to write there. But you'll notice there's 3 of them, so it's 3 factorial. None of them are the same, but I do have to times by 6 because I've already worked out there are 6 ways of arranging the vowels once I put them together. So 3 factorial is 6 again, times 6 is 36. I'm hoping the answer says 36. Yes, it does, and they've done it the same way as me. Last question of this type. How many permutations are there of the letters of the word exaggerate if the vowels must be kept together? Well, again, how many vowels are there? There's an E, there's an A, there's an E and A, and there's an E. So there's lots of vowels, but there's lots of repetition. How many ways of arranging those? Well, it's 5 factorial, divided by the fact there's 3 E's, divided by the fact there's 2 A's. So that in itself is just working out how many different ways of doing that is something we need to be able to do. And I get 10. I'll take that. Yeah, that as being true. Now, if I have my vowels now, what else have I got? I've got an X, a G, an R, and a T. And of course my vowels. I'll put a V. V is quite handy as a vowel letter there. So 1, 2, 3, 4, 5, 6. 6 factorial. Oh, there's 2 G's, divide it by 2 factorial. Don't forget to times by this 10 number I've got here. So what is that as an answer? I get 3,600. Good, 3,600 seems to be the answer. So on this next question, we're going to look at we're going to look at keeping things separate, and I've talked about this in terms of splicing things together. This rope here, it has a red and a blue and a sort of cream coloured rope, and I've tried to show you that I've kept them apart. They've been spliced between each other, so that basically they kind of mix, but they're always separate. So this first question says, how many permutations of the word trouble have none of the vowels together? Well, first of all, what are the vowels? It's an O, a U, and an E. Now, the way to do this question is to identify what I'm going to call the separating objects. And here, obviously, the things that I'm going to have to use to separate these vowels, because they're not allowed to be like that. They have to be separate. Now, I've got 4 opportunities to keep these O and the U and the E separate. So the way I would think about that is to permutate the separating objects. I've got a T, an R, a B, and an L. So a T, an R, and a B, and an L. Now there are 4 factorial ways I could use. I could put these into my arrangement. Yeah, the R could be the front, the T could be the end, whatever. There's 4 factorial ways of doing that. But notice then the vowels can go into any of these slots. This question doesn't say the consonants have to be apart as well. These consonants could theoretically, for instance, I could have an O, then a TR, then a U, then a B, then an L, then an E. As long as my 3 vowels are apart, that's fine. Notice the B and the L and the T and the R aren't apart. That's fine. I can do whatever I like. So having got to this stage where I've worked out how many ways of keeping working out how many ways of arranging my separating objects, notice I can go then 1, 2, 3, 4, 5 places. Interestingly, that's always 1 more than the number of separating objects, because you've got the extra place at the ends. So I then identify the 5 ways of putting my vowels, and I could have a vowel here, 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 whatever. And basically I then have to work out how many places I need to use. Well, there's only 3 of them. I need to use 3 of these places. Now that's actually an example of, if I like a P, in this case it is, I've got 5 slots and 3 things to put in them. Now one way of doing that is saying this first one, I can put it in 5 places. This second one, once I put one in, there's 4 places left. The third one's got 3 options, and I can just times them all together. But this, just bear in mind, is 5p3. So I've got 4 factorial from the separating objects, 5p3 from the vowels, the things I want to keep apart, and that gives me an answer of 1440. Here's an example of that. In how many different ways can 6 girls and 4 boys be arranged? Now I've got a form at the bottom, but I don't really want to use this just yet, but this is really what I'm doing. So I've got this separating object. I want to keep the boys apart. Notice the boys, there's less boys. I think if there was more boys, I wouldn't be able to keep them apart. So I think you'll always get the smaller number being the one that you want to keep apart. So I'm going to say the separating object, well, there's 6 of them, so it's 6 factorial. There's 1, 2, 3, 4, 5, 6. I think I need those. I can put girls in any of these slots. Is that enough? 1, 2, 3, 4, 5. No, it's not. There, now I've got 6 girls. Now, they're all different, so there are 6 factorial ways of doing that. But now the boys, there are 7 places for them to go, because it's 1 more than the 6. So I can times that by 7 times 6 times 5 times 4. I want 4 of them. Again, I could have written that as 7p4. So if I just do that now, I've got 6 factorial times by 7. I'm going to write 7p4 just because it's quicker, and I get 604,800 when I times the 6 factorial by the 7p4. Good, that's what I wrote down before. And so this formula, if you like formulae, that might be a way to think about this. I've got A objects, and I've got B objects. The bigger of the two number, I basically do A factorial. I add 1 to it. A plus 1, notice that's my 7 rather than my 6 because of the ends. P, B, A plus 1, PB. So I suppose we're getting ready for the next lesson. We've got an exercise here. What I'm going to do is I'm going to try just give you a chance to have a go at this, or perhaps practice this now. See if you can get 3 answers. Pause the video and then I'll put the answers up in a bit. But definitely have a look at this, please. So I hope you have had a go. I'm going to have a look now at doing this as well. Question A, what's it say? Question 1A. Alphabet. A's can go anywhere. Well, 1, 2, 3, 4, 5, 6, 7, 8. So I just think that's 8 factorial. I've then got to divide by the fact I've got 2 A's. So I still have to divide by them because they're identical. But any other letters which are the same? I don't think I have. I think it's just 8 factorial. There's 2 factorial. So just do that now on my calculator. 8 factorial divided by 2 factorial. I get 20,160. A's together, well, again, just treat this now as, that was part 1. This, you just treat them as one letter. So that effectively just means I've got 7 factorial. But now I haven't got any repetitions. So it just changes the type of question slightly. And therefore, 5,040, much fewer. You keep them together, it seems there are much fewer ways of doing it. So I've got 2 answers so far. And mathematics, it says, where the A's are at the beginning. So part B. Now, how many A's are there, first of all? There's a double A. Now, interestingly, you put a double A at the front. There's only one way of doing it. So they are at the game. They're at the front. So whatever else have I got? I've got 1. So I'm just going to cross these out. Probably easiest. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm now looking at 9 factorial. No restrictions on these, but obviously the m's are the same, so I divide by the 2 factorial. I've got 2 t's, divide by the 2 factorial. Yeah, I think that's it. 9 factorial divided by 2 factorial divided by 2 factorial. Just typing that in my calculator. I get 90,000 ways of doing that 720. So it'll be interesting to see if they're right in a bit. Oh, I just noticed the time. We are running out of time. So here are my answers. Interestingly, I got those first 3 right. Hopefully you've got the questions 2 and 3 right. Have a word with me in class if you didn't. And then in class, what we're going to do is look at exercise 1F. Lots of questions to do, and it's just, these complicated questions where we're asked to keep things together or we're asked to keep things apart. So get ready for them, and we'll see those in class. All the best.